Okay, so a bit of revision on sequences, and we're going to go right back to basics and think about there's two types to define the sequence. There's something called decision to term rule, which that's the one you're most used to. That's like an nth term where I can put un equals something like 3 over n add 1. Yeah, so to get the first few terms, to get the first one, I would sub in 1, so 3 over 1 add 1, this means 3 over 2, u2 is 3 over 2 add 1, which is 1, u3 would be 3 over 3 add 1, which gives me 3 over 4, etc. Yes, that's like an nth term. The other one is what's called, not position on the writing, term to term rule, and that's when instead of saying how to get to any specific number, you tell people how to get to the next number. So we write that one as something like un add 1 is 3 over un add 1. And for this one, we'd have to tell you where to start. So I'm going to let's pick a nice number. Say we start at 1. So to get u2, what I do is I don't sub in 2. I want this to be u2, so that means n is 1. So it's 3 over u1 add 1. u1 is 1, so it's 3 over 1 add 1, so that's 3 over 2. u3, I don't sub in 3. I want this to be 3, so n is 2. So it's 3 over u2 add 1. So that's 3 over 2 add 1. That I can't do in my head. So 3 over 1.5, 1 gives me 6 over 5, etc. So this method, this is the one where you probably would have did at school, you probably would type this in. You would have typed in 1 equals, then you would have done 3 over answer at 1, press enter, gets 3 over 2, enter 6 over 5, enter would be the next one, keep press enter, gives you the next few terms. Yeah. Now, if I wanted to, for example, on this one, if I wanted to work out the sum for UR from 1 to 10, I could do that using my calculator, just by doing this like calc. Go along to sum. I'm going to use x instead of r, so it's 3 over x add 1 from x equals 1 to 10, and it will give me my sum. Yes, that's working out all 10 terms and then adding them together. Whereas if I wanted to do this one, there's no way of using the sum button on my calculator to do it. Instead, you need to work out the first 10 terms and then add them together. So that's different. So if I ever give you this as a starter or question, where it's un plus 1 and un, you can't use the sum button. Instead, you have to write out all the terms and either auto pad in or add each individual term together. Okay, so what we're going to do now is we're going to talk through 2 exam questions so you can see how they work. Then you're going to have to go and do them yourself. So let's see if I can get this to work. So hopefully in a second you should see my screen. Now if I do that. Okay, so I've also set this as your assignment. You can have a read of this separately. So just have a quick read of the exam question on the board. Okay, so I'm going to read through it. So we've got a sequence at the top, k is a constant, and k is not equal to 0. Find an expression for x2 in terms of k. So straight away, it's telling me I need x2, but the important bit is it's going to be in terms of k, it's not going to be a number. Okay, so in order to do that, I'm going to use the sequence. So to get x2, that's x1 add 1, so it's x1 squared, take the word k, x1. But we know that x1 is 1. So I'm going to sub in x1 equals 1. And I'm going to get 1 squared, take away k times 1. So that's just 1 take away k. So x2 is 1 take away k. Okay, part B. Show that x3 equals 1 take away 3k plus 2k squared. Well, the key bit there is show that. So that means we pretend we haven't seen the answer, then we have to derive it. So we've got x2, so we can use that to get x3 using the formula. So x3, I can write that as x2 add 1, which means it's x squared take away k times x2. But we know what x2 is. It's 1 take away k. So sub that in. So it's 1 take away k squared take away k times 1 minus k. So expand it. So 1 take away k squared expands to 1 take away 2k plus k squared. Minus k times 1 minus k gives me minus k plus k squared, because minus k times minus k is positive. And then simplify that to just get 1 take away 3k plus 2k squared. So that's part B. Okay, then we're told that x3 is 1, and we're asked to calculate the value of k. So, well, x3 is 1, so that's important. And to find k, well, we know what x3 is in terms of k. It's 1 take away 3k plus 2k squared. Make that equal to 1. Now I'm going to take away 1 from both sides to get a quadratic. Now I'm going to solve that however you like. You factorize out k, you could type in your calculator, you could use the formula, you could even complete square if you want to do. And we get two answers, k is 0 or k is 3 over 2. But we're told right at the top that k is not equal to 0, so that means k must be 3 over 2. Okay, so that gets us all 3 marks, wasn't too hard. And the last bit, hence find the value of the sum from 1 to 100 xn. So that just means the first 100 terms added together. So they're not going to want you to write out all 100 terms, so there must be some kind of pattern. So always start off by writing the first 3 numbers out of the first 3 terms. So we have the first one was 1. The second one was 1 minus k. So sub in what k is, gives me minus a half. The third one was 1. So it's going 1 minus a half, 1. So the next one will obviously be minus a half. So it's periodic of order 2. So there's what the sequence looks like. And now with the first 100 terms, so that means that I'm going to have 50 lots of 1s and 50 lots of minus a halves. So work that out, add them together, we just get 25. So that sum there is 25. And that last bit, you go and check using a calculator because it's an iterative sequence, it's a term-to-term sequence. Okay, so altogether that was 9 marks, and we did it in, well, less than 5 minutes, although it might take a bit longer to do the working out, the algebra. And next one. Now this one is a tricky one. This one's from the new spec, so they've made this one trickier on purpose. So we have this sequence of numbers A1, A2, A3, defined by AN plus 1 is k take away 3k over AN. That little bit at the end just means n is positive integers. So n is 1, 2, 3, 4, 5, etc. K is constant. The sequence is periodic 1, 2, and A2 is 2. Show that k squared plus k take away 12 equals 0. So at the minute, that show that bit, it looks a bit weird. Where are we going to get a squared from? There's no squares in the question. It hasn't really told us anything to do. So instead, let's break down the question into bits we know. So we know that it's periodic of order 3. So that means that the numbers repeat themselves every 3 times. So the first number is equal to the 4th number, which is equal to the 7th number, which is equal to the 10th number, etc. The second one is equal to the 5th, the 8th, the 11th, etc. The third is equal to the 6th, the 9th, the 12th, the 15th, etc. So I've written it horizontally at the minute. I could also write that vertically at that. So the first 3 terms, they're all different terms. But then after that, all the other terms copy it. So that fall into the same column like that. So that first column are all the same number, second column is all the same number, third column is all the same number. So there's only 3 different numbers. They could all be the same. Potentially 2 of them could be the same, but at most there's 3 different numbers. Okay, so that helps me because I also know that A2 is 2. Now if A2 is 2, that whole column is 2. In particular, A5 is 2, that's my next term. So what I'm going to do is I'm going to work out what A5 is in terms of care, make it equal 2, and solve it. So if A2 is 2, then I'm going to work out A3. So A3, I'm going to sub in A2 is 2, so I get K minus 3K over 2, which is the same as 1K, take away 3 over 2Ks, which simplifies to me minus half K. Then I can sub that back in to get A4. So A4 is K, take away 3K over minus a half K. Well, the K's cancel out on that fraction, and my minus 3 over minus a half is plus 6. So A4 is K plus 6. And I can sub that back in to get A5. So A5 is be K, take away 3K over K plus 6. But we know that A5 is 2, so that little expression has to equal 2. So now I just need to rearrange that to make it equal 0. So I don't want a fraction, so I'm going to times both sides by K plus 6. So 2 lots of K plus 6 is K lots of K plus 6. Take away that 3K, so cancel out the bottom fraction, expand the brackets, and then take it all to one side, and I get the quadratic they've said. So you can see the difference between this one and the last one. It's a bit more working out to get marks, a bit less structure. Okay, so the next bit tells me that A1 does not equal A2. And we want to find the sum from 1 to 121 of AR, so the first 121 terms added together. Well, if A1 doesn't equal A2, I know that A2 is 2, so I know that A1 doesn't equal 2. And if A1 doesn't equal 2, that whole column doesn't equal 2. So A4 doesn't equal 2, A7 doesn't equal 2, etc. Now I've got an expression for A4. If you look back in the working out, A4 is K plus 6, and I know that doesn't equal 2, so I need to work out what K could be and use that to tell me what K is. So I've got a quadratic for K, solve it to get K is minus 4 or 3. So if I sub them into A4, if I sub in minus 4, I get A4 is K at 6, so minus 4 at 6 is 2. But I know that A4 is not equal to 2, so K can't be minus 3, so K must be 3. So sub 3 in, so K at 6, so 3 at 6 gives me 9. So therefore, K is 3. So my first term is 9, because A1 is 9, A4 is 9, A7 is 9, so that first column is 9. The second column is called 2, so that's what the question told me. So all that's left to work out is what are all the numbers in that last column. Well, A3 is minus a half K, K is 3, so A3, I just times them together, so A3 is minus a half times 3, so minus 3 over 2. So that's periodic, and it goes 9, 2, minus 3 over 2, 9, 2, minus 3 over 2, and it's going to keep on going on like that. Now I want to add together the first 121, so when I group them into 3s, I need to think how many groups of 3 will I get from 121? Well, 40 times 3 gives me 120. So I'm going to have 40 lots for the cycles, 40 lots for the periods, plus the 121st term. So I get 40 periods plus the 121st term, which is going to be equal to that first column. So the 121st term is just the first term, which was just 9. So I'm going to do 40 lots of the first 3 numbers added together. So that gives me the sum of the first period. Then I'm going to add that 9 onto the end, and I get 3, 8, 9. So can you have a go at trying some of those questions yourself?